All right, what's up, guys? It's been a while, but here I have a cool little concept for you guys, something called the Triangle Inequality Theorem. So let's draw a triangle. We all know what those are, so let's draw one. So let's say I have a triangle like that. What the Triangle Inequality Theorem tells us is that if we have lengths, let's call this length A. We don't know how big it is. Let's call this length B, and then let's call this length C, right? So A is this vertical bar, B is this horizontal leg, not bar, they're called legs, and C is this leg on the triangle, the largest one, okay? What the triangle inequality theorem tells us is the following, okay? In order for three sides to make a triangle, then the sum of two legs must be greater than the other leg, than the last leg. So if you add two legs up, they have to be greater than the third leg. And since there's three legs, there's three possibilities. So here I added A plus B. Well, it's another possibility. Well, we have A plus C. And that has to be greater than, what's the other third one? In this case, it's going to be B, right? And then there's one last possible combination. We used A twice already, so that means we have to use B plus what? C. And that has to be bigger, greater than A. So a triangle can only be formed when these three conditions are met. Okay, so let's keep that in mind. So here I'm gonna provide an example, all right, of the triangle inequality theorem. Let's say we have a triangle, and let's just give these guys random numbers. So let's say this is 3. Let me use a different color. Let's go with blue. So this is, let's say instead of A, B, C, we have 3, right? This here is 3, right there. Let's say this one is 4, and let's say this one right here across is 5. Do those make a triangle? If we have those lengths, 3, 4, and 5, do they make a triangle? Well, let's test the triangle inequality theorem to see if we do get a triangle. 3, 4, 5 is the ones we're going to play with, all right? So let's do the first possible condition. So A plus B, so in this case is 3 plus 4. So 3 plus 4, is that greater than 5? Well, yes, because 7 is greater than 5. So this condition is met. Let's try the next condition, okay? So I'm just gonna leave it as a sum. You guys don't need me to like add 3 plus 4. You guys are smart enough for that. So that one's met because 7 is greater than 5. Let's try the next one. A plus C. So A is 3 plus, well, C is 5. Is that greater than 4? Well, yes, because 8 is greater than 4. So we're good so far. Let's try the next condition, the last one. B plus C. So in this case, we have 4 plus 5. Is that greater than 3? Well, yes, it is. So because all three conditions were met, then a triangle with side lengths 3, 4, 5 do make a triangle. So this makes a triangle. Good job. Let's try some other numbers to see if they make a triangle. What if we have triangle? Well, here I actually have something for you guys to see. So this is a triangle inequality theorem, all right? So I'm going to go to a new page. So here we have 3, 4, 5. We checked it earlier that they do make a triangle, okay? Let's see if they actually do though. So to make a triangle, they should connect. So I'm gonna take this piece and I'm gonna duplicate it so that I keep the same dimensions. Boom. So there's this length, okay? 3. So they're corresponding by color. They're both red, but I don't want to keep saying it's 3. It's just 3. You can count the spaces, right? From here to here. 1, 2, 3. This is 4. 1, 2, 3, 4, and this is 5. 1, 2, 3, 4, 5. So I have 3. Let me duplicate this one. Here we go. Duplicate. So we're going to bring this down here. Oh, let's drag it down here. And we're going to take this last one. And we're going to bring it down here. Let's see if the triangle inequality theorem was correct, right? Let's just check it out. We said they form a triangle, so let's see if we can form a triangle. So I'm going to take this piece and I'm going to rotate it just so we can connect them to a triangle, right? So I'm going to connect them to a triangle. So boom, that piece connects right there. And let's take this piece now and let's move it over. So we have to connect it. So I have to rotate this bad boy. Oh, looks like we have to do a little bit more rotation to make them fit. All right, that connects. Looks like I gotta make this one straighter. Oh, look, it looks like they are gonna make a triangle. Let me just adjust them a bit. And we can see that 3, 4, 5 does in fact make a triangle. So we're good there. Good job. But let's check something. Let's check if these dimensions make a triangle. 1, 3, 5. So we're gonna go back here. We're gonna check if these conditions make a triangle. So we have 1, 3, 5. So let's say that instead of 3, 4, 5, we have 1, 3, and 5. If you're given these lengths, does it make a triangle? Well, let's find out. A plus B, so we have 1 plus 3. Is that greater than 5? Oh, we run into a problem. It is not greater than 5. That's not good. Well, let's just keep going, okay? So this one failed already. Let's try the next one. A plus B, no, A plus C, so 1 plus 5. 1 plus 5 is greater than 3. Well, that one checks out. Yeah, 6 is greater than 3, so that's good. And let's check the last one, B plus C. So 3 plus 5. So 3, let's stick with the colors. 3 plus 5 is greater than 1, right? Well, that's true. 8 is greater than 1, so that's good. But as we can see, 2 of the conditions were met, but the first one was not met. So if you have side lengths 1, 3, 5, according to the triangle inequality theorem, they don't make a triangle. And here I'm going to show you. I have 1, 3, 5. I already duplicated the lengths to speed it up. Let's see if we could connect these things to make a triangle. So here I have this. So first, let me rotate this purple one. Let me put it like that. Boom, right there. Let's see if we can connect this 3 one right here. All right, let's connect it. Right there. Oh, we're running into a problem. Look at that. Well, what if I just rotate it as much as I can, right? Right there. And then let's try rotating this one. We're going to try to make the triangle. Oh, they don't make a triangle. You see that? So these conditions, the first condition was not met. Therefore, if one of these conditions fails, the side lengths do not make a triangle. It is not possible. All right. And we can see a visual representation right here that the triangle inequality theorem does hold. So let's do another exercise and then we'll call it a day. So let's try, let me erase all this now. And instead of drawing the triangle, I'm just going to straight up give you the side lengths. So let's see. We have a triangle with side lengths. All right, let's assume we have side length. Let's just give us side lengths. Let's go with 3, 3, and 2. 3, 3, 2. Does that make a triangle? Well, first let's just label them A, B, and C. It really doesn't matter which sides you label what, because we're gonna do different combinations, different combinations of summing the sides. So it really doesn't matter which side is which. So let's try it out. So in this case, we have A plus B. So 3 plus 3 is greater than 2. We're good. Let's try another one. Instead of, we already did A plus B. Let's try A plus C. So this time we're going to have 3 plus 2 is greater than 3. Oh, wait, that's true. So far, so good. Let's do a different color. We did A plus B. We did A plus C. So now let's do B plus C. Again, 3 plus 2 is greater than 3. Hey, look at that. It holds. So if we have a triangle with 3, 3, and 2, it will make a triangle. And let's just make one right here. So 3, 3, 2 were the conditions. Yeah, 3, 3, 2. So here I'm just going to change this. Okay, so I'm going to erase these, erase that, and erase that. And we're going to increase this one. So it's 3 in length. Okay, so here we go. 3, 3, 2. Oh wait, if there's well 3, 3, 2, I can just copy that one. So let's get rid of this one. We don't need it. And we're going to duplicate this one. And we're going to change the color just so it's different. So we're going to wear purple. So we have 3, 3, and we have to take this side and make it smaller. So 3, 3, 2. 3, 3. So that's still too big. So let's make it smaller. I did that. So they're rectangles because they're easier to rotate that way. So let's just take this one and let's make this one too. So we're going to put it there and we're going to decrease it to length 2 right there. All right, cool. So now we have 3, 3, 2. Okay. You can count them in order to see. Watch. 1, 2, 3. And we're going to take it right here on the right. 1, 2, 3. All right, we're good. Let's see if we can make a triangle. Because the triangle inequality theorem said we can. So let's take them and let's move them around, all right? So we're going to take this one and we're going to bring it, let's rotate it and bring it right here. You might need to rotate it more actually. All right, right there. And let's take this one and let's rotate it and let's bring it over here. All right, they're not connected yet, but let's see if we can get them to connect. Oh, it looks like they will. It looks like they can connect. What do you guys think? Oh yeah, they're gonna connect, all right. So let's just keep moving it. I'm comfortable saying that they connect. Yep, they connect. Look at that. Boom. So 3, 3, 2 does make a triangle. And the triangle inequality theorem proves it. And that's really it.